So this is the next part of this topic. We have the length of a chord. So what is a chord? A chord is a line that is drawn from one part of the circumference to another part of the circumference. So let me give us okay, as you can see, we have a circle here, and let me draw a chord for this circle. So let me draw my chord this way, from this point to this point here. So let me call here my A and call this B. So this is a chord called AB. So from this center here to this part or this point is my radius. I can have another line drawn from here to this part. This is still my radius R. So we want to get the length of this chord AB. So what is AB? Our main aim here is to get AB. So let me write it somewhere here, AB. So we seek to find AB. So, and this is the center O. So any line in SS2 work, you will look at cycle theorem. So this is one of the theorems there, that any line drawn from the center of a cycle to meet a chord like this. If you draw a line from the center of a cycle to meet a chord, that chord will be bisected. Yes, because it will make a perpendicular with that chord AB. And as we know, all radius are equal, so AO is the same thing as BO, so they are the same. So any angle formed here, before I draw this, let me see, we have theta here. As usual, we have theta here. So since I've drawn this line here to bisect the chord AB, since I've drawn that line to bisect the chord AB, definitely theta will also be bisected. And if theta is bisected, that is, it is divided into equal parts. So here becomes, I had theta initially before here. Yes. So if I dividing this angle here means that here becomes theta over 2. I'm sorry, it's not clear. Also here becomes theta over 2. Yes. So from here we can now determine the length of the chord. But before that, I just said that a line drawn from the center bisect the chord. So meaning that the whole of AB is bisected. Take for example, if AB happens to be 4, that means since it's bisected, that means each part we take 2. So here we take 2, and here we take 2. Also, if AB is 10, for example, since this line, let me call here this point D, since this line OD is bisecting this chord, that means, like I said, if AB is 10, so this part here AD will become 5, and D to B will become 5 also. So whatsoever length my chord is, once I have a line drawn from the center to meet that chord, the length of the chord will be bisected. So that's a rule you should know. It's a rule you should know. So now let's look at how to solve for AB. Okay, so as you can see now, we have a diagram redrawn. So I had to draw a neat diagram from this circle. I had to extract the triangle from this circle. I know that the triangle from there is an isosceles triangle because, as you can see, that the radius is OA is the same as OB. Yes, so a triangle having two sides equal is known as isosceles triangle. Yes, and so that was why I drew in this triangle. If you draw a if you draw a line from the top to meet the base, it is bisected. So that is, it has this property. So you must know it. So originally the angle the angle AOB entirely was just theta. Angle AOB entirely was theta, but this line I drew is a bisector, so it now divided theta into equal parts. So that was why you have theta over 2 here. So um now you can take one part of this triangle. Yes. So let me take triangle OBD. Yes, the two triangles are congruent. They're the same exactly. They are the same, so you can pick any of them. So don't forget that we're trying to get the length of the chord AB. So, and that reminds me, chord AB, as we are seeing here, chord AB should constitute of AB should be equals to adding AD and adding AD, that's from here to here, adding AD and also adding DB. Yes, so AD and DB. So, and also don't forget that, like I said, AD and DB are the same. They are exactly the same because the this line here OD bisected AB. So making this angle to be divided by 2. Yes, and also making this base AB to be divided by 2. So AD and DB are the same thing. So let's see, if I've gotten DB, then I've gotten AD. So let's see it now. So as we can see here, we have one part of the triangle taken already. So let's look for DB. So now looking at DB, if you watch, this is the angle, right? Yes, and like I told you in class, anywhere the angle is facing is your opposite. Anywhere the angle is facing is your opposite. So this is my opposite, and anywhere angle 90 is facing is called the hypotenuse. So why this side takes the adjacent. So as you can see, I don't have any business with the adjacent. My main aim is to get the opposite. We want to get the opposite. That is DB. I want to get DB. So we are using the opposite and the hypotenuse. I don't have any business with the adjacent. Don't forget that I'm trying to get the length of the chord. So DB is part of the chord. So my focus is on DB. So that is the opposite, and we are giving something on the hypotenuse, that is the radius. So this is sine from SOHCAHTOA. Opposite and hypotenuse is sine. So we go, I will say sine. What is the angle here you're saying? Sine theta over 2. Sine theta over 2 is equals to opposite, as we know, opposite over hypotenuse. So sine theta over 2 is now equals to, what is the opposite? Is dB or BD, anyhow you call it. dB over what is the hypotenuse? It's R. The hypotenuse is R, just R. So what can we do here? Let's call here over 1, cross and multiply. dB times 1 is dB equals to R times sine theta over 2 should be R sine theta over 2. Yes, so we are there. So dB has been gotten as R sine theta over 2. Like I told you that if we've gotten dB, if we've gotten here, then we've also gotten here AD, because they are the same. So therefore AB, which is the length of the chord, is now equals to AD is the same thing as BD, or dB. AD is the same thing as dB. So what is dB? dB is r sine theta over 2. So I can write here as r sine theta over 2, since they are the same thing. R sine theta over 2 plus dB itself is still the same thing, r sine theta over 2. So these two are the same thing. So since they are the same thing, there's no number at the back, so I can put a 1 here as coefficient, putting a 1 here as coefficient, so that 1 r sine theta over 2 plus 1 r sine theta over 2 should give us 2r sine theta over 2. And yes, we're here. So this is the formula of finding the length of a chord. I could not do it in class because it might take time. So I think it's not understandable here. Yes, because some of you might be asking how come this formula. So you've seen how it was derived. Yes, it was derived just this way. I did it. So the length of a chord is 2r sine theta over 2. So having seen this, let's now go into solving problems using this formula. But if you cannot understand the formula, maybe you can rewatch the video as many times as you can. But if you don't understand still, no problem. Just learn the formula. Just know that the formula of finding the length of a chord in a cycle is 2r sine theta over 2. Yes. I doubt if you'll be asked to prove it in an exam. But just know it, just the way you know how to find, just the way you know the formula of finding area of a rectangle as length times breadth or length times width. Just know this formula, that finding the length of your chord is just 2r sine theta over 2, and that's all. But if you care about the proof, now it's here for you. So let's look at some questions under it. So the first question here is the angle subtended at the center by a chord of radius 6 cm is 120. Find the length of the chord. So you've heard that sentence, find the length of the chord. Okay, so you should apply the formula of finding length of chord straight away. So let's see, number one here. So let's write down the information we have here. Sorry, they said the angle, okay, radius is 6 cm and the angle is 120. Radius is 6 cm, that's my r. My r is 6 centimeters, and the angle is 120 degrees. So we are asked to find the length of the chord. Let's call it L. Please don't confuse this with length of an arc. Yes, so I'm dealing with length of a chord now. So for this, in this part, anywhere you see L in this part, I'm referring to length of the chord. Or you can call it any other thing you wish to call it. Use any variable to denote it. No problem. So length of the chord, from the formula, we know that L is equal to 2r sine theta over 2. Yes, 2r sine theta over 2. So everything here is given to us clearly. So we have L equal to 2 brackets what's your R? Your R is 6, so you write down 6. Sine theta is 120 here, so let's write 120 over 2. So L is now equal to 2 times 6 is 12. 2 times 6 is 12 times, what is 120 divided by 2 is 60. So we have sine 60 degrees. So L is now equal to 12 times sine 60 is, the angle is special, so 60 should be root 3 over 2. 60 should be root 3 over 2. Root 3 over 2. Yes, so L is now equal to 12 times root 3 is 12 root 3 all over 1 times 2 is 2. So 2 in itself 1, 2 in 12 is 6. So L is now equal to 6 root 3 centimeters. 6 root 3 centimeters. Well, peradventure, you know, since this angle is a special angle, so you're meant to leave your answer in short form. Okay, but if you want to get the approximate value of this, I think we can begin from here. If you want to get the approximate value of this from here, let's solve again. I left my answer in short form, but if you want to get the approximate value, we can still go this way by doing L equal to 12 times, what is sine 60? On the table, if you check the table of 4 figures, sine 60 is 0.8660. Yes, then L is now equal to, multiply 12 by 0.8660, you will get 10.392 in centimeters, which I can choose to approximate to 1 decimal place or 2 decimal places as you like or as you wish. So L is now equal to, let me approximate to 2 decimal places. So the first decimal place here is 3. Sorry, the first decimal place is 3 and the second decimal place is 9. What is next to this second decimal place is 2, not up to 5. So I'll round down and my answer becomes 10.39. Since the digit next to 9 is not up to 5, so I can't take 1 from here and add here, no. So I'll leave it that way as 10.39 centimeters. So this is my answer. This is my approximate answer to 2 decimal places. 2 decimal places. But if you want to leave your answer in short form, you can go this way I just did. But to get the approximate answer, you can, from this place where I circled, you can now continue and then get your answer in decimal. So that's it. Let's see the next question. So number 2, a chord of a cycle 8 cm long. So before you start solving, always know what each figure is representing. So a chord of a cycle 8 cm long. So that means my L is 8 cm. That is the length of the chord. Length is 8 centimeters. Okay. Subtends an angle of 150 at the center. Find the radius. So the theta here, our theta here is equals to 150 degrees. So to find the radius, which we don't know, so this problem is problem on length of a chord. So write down your formula, please. Length of a chord. So length of chord, as we know, is equal to 2r sine theta over 2. Yes. So now my L is 8 centimeters. I'll have 8 here equal to R. Okay, we don't have R, so we are looking for R. So I have just 2R repeated here. Now sine, but we have theta. Theta is 150. 150 divided by 2. So 8 equals to 2R sine. So 150 divided by 2 should be 75. So we have 75 degrees. So 8 is equal to 2R. What is sine 75? Sine 75. Sine 75 is we have 2R times is 0.9659. 9659. Yes, sine 75 is 0.9659. So multiply it by 2R. Multiply 0.9659 by 2.9659 by 2. We get 1.1318. So multiplying by R as well should be 1.9318 R. So to get my R, I'll divide both sides by 1.9318, dividing by 1.9318. So 1.9318 we cancel out here. R becomes equal to, so 8 divided by 1.9318 is giving us 4.4 point 4.1412 and so on. It's a long decimal in centimeters. So let me approximate just to 2 decimal places if you want, or you can approximate to 1 decimal place. So R is approximately, let's do to 2 decimal places. The first decimal place here is 1. Yes, and the second decimal place here is 4. So this is my target here, 4. So what is next to 4? It's 1, not up to 5. So I'll round down and my answer becomes 4.14 centimeters to 2 decimal places. So that's our answer for question 2. So let's look at the next question, number 3. In the diagram below, O is the center. Calculate the length of the chord AB, and so on. So we are told that if OA is 5 cm, that is OA. If OA is 5 cm, OD. So it's clear. So let's redraw this diagram properly. So if I redraw this diagram, we'll have something like this. So we are told that OA is 5 cm as well. So OA is 5 cm. OA is 5 cm. So we are asked to calculate the length of the chord. Length of the chord. So looking at it, the length of the chord here is just AD and DB. Length of the chord here is AD and DB. Like I told you, whenever you have a cycle and a chord drawn this way as AB, any line that runs from the center to the chord bisects the chord. Bisect means that it divides the chord into equal parts. So meaning that whatever distance AD is, DB is that same distance. So it then means that it then means that if I can get um if I can get DB, then I've gotten AD. So how then can we solve this? We can solve this faster using Pythagoras theorem. So let's see, the chord is AB. From the diagram, the chord is AB. Yes. So an AB here, an AB here is equals to AD plus DB. So let's get DB. So I can get DB, or let's get AD, whichever is the same thing. So getting AD, that is, I need this place here. If you don't understand, trying to do something like this. I'm trying to redraw this diagram. Sorry that it's not straight. Just manage. This X, this 5 centimeters. This angle 90, and this 3 centimeters. So I'm trying to do something like this. So getting here, I'll use Pythagoras rule, which state that the square of the longest side. So what is the longest side? We are asked to get AB, so keep this somewhere. So to get AB, I need to know AD. If I know AD, I've known DB. So we're trying to get AD from here. So from Pythagoras theorem, it states that the square of the longest side, OA square, is equals to the sum of the squares of the other side. So what is OA? OA is 5. OA, OD. Oh, sorry, I made a mistake. Sorry. It should be like I'm labeling here. Let me show you. I'm using here as A, O, and D. Yes, the square of the longest side. The square of the longest side is OA plus the other side OD, and then the last side AD. Yes, I'm using triangle AOD. So what is OA? OA is 5. Square it. OD is what? 3. Square it. AD is what we seek to find. So 5 square is 25. 3 squared is 9. Then plus AD squared. So taking like terms here, 9 comes to the left. I will have 25 minus 9 equals to AD all squared. And 25 minus 9 is 16, equal to AD square. So to get my AD, I will take the square root. For this square to go out, I will take the square root on both sides. Here becomes the square root of 16 equals to AD. And therefore, AD becomes equal to 4. Yes, centimeters. And like I told you, once I've gotten my AD, I've gotten DB, because they are the same. Why? Because OD bisects them. That is the rule. That's the theorem. So AD now becomes 4 centimeters. AD becomes 4 centimeters. Since AD is 4 centimeters, also DB will become 4 centimeters. So that when I add them all together from this thing I wrote here, yes, the length of the chord is AB. The length of the chord is AB. Don't forget that the length of the chord is AB. And to get AB, to get the whole of AB. To get the whole of AB, begins from here and runs to here. Yes. So to get the whole of AB, I must need AD and DB, which Of course, they are gotten now. So therefore, the length of chord is now equal to 4 plus 4. L is equals to 8 centimeters. So the answer to this question is 8 centimeters. Okay, now this same question can be solved because I know some will be asking me, Master or Sir, you did not solve using the normal formula. You did not solve using the normal formula. So yes, this can be solved using that normal formula of L equals to, let me write it down. It can still work with that same formula. We had as L equals to 2R sine theta over 2. Yes, it still works very well. Yes, just that I feel the Pythagoras theorem is much more easier here since we know two sides of this triangle. To get the third side is just using Pythagoras, and then since these two sides are equal, I add them up. So that was much effective. But if you want me to solve using this formula, it's still possible. So now let's solve by this formula here. Already we know our radius from the question. We are told that the radius is 5 meters. Yes, even looking at the diagram, line from center to the circumference is 5, so the radius is 5 centimeters. So I'm told that OA is 5 centimeters as well. So now I told you of something while I was deriving this formula, that any angle I have here, any angle I have at the center, once OD passes through that angle, it bisects the angle into two. So let's say the angle at the center is theta. So since this line has passed through and bisected it, it becomes that here becomes theta over 2. Also here becomes theta over 2. Yes. So to apply this formula, I still need to get DB or AD. Yes, this two triangle AOD, AOD is just congruent to triangle BOD. So let's work with one triangle. So let me work with triangle BOD. Let me work with triangle BOD. Let me show you something. Don't mind my sketch. So this is my B, this is angle 90, this my D and O, center O. This is theta over 2. This is 3 centimeters and this is 5 centimeters. So I need to get sine theta over 2. That is just the idea here. I need to get theta. How do I get sine of theta over 2? Yes, we have theta over 2 here. So what is the sine? Don't forget that sine means opposite over hypotenuse. Good. Sine of any angle means opposite over hypotenuse. So we need to get the opposite. This is the angle here. Theta over 2 is the angle. Anywhere it's facing is my opposite. My opposite. Anywhere angle 90 is facing is my hypotenuse, while the other side takes the adjacent. So let's now get sine. Okay, before I can get the opposite, I must apply Pythagoras theorem, which we've applied before. So I'll be faster now. We state that of the longest side, the square of the longest side, let me call this unknown side x, for example, or for instance, let me call it x. Let me call it x. So from Pythagoras theorem, it states that the square of the longest side, you saw how I did it before for triangle AOD. So what is the longest side here? Is 5. So the square of the longest side is equals to the sum of the squares of the other side. I will have 3 squared plus the other side is x, so I'll have x squared. So 5 squared becomes 25 equals to 3 squared is 9 plus x squared. So I will have 25 here. 9 comes over to the left and I have minus 9 equal to x squared. 25 minus 9 gives us 16 equals to x squared. To get my x, I must take the square root of 16 or of both sides. I have that the square root of 16 is equal to x. So therefore, x becomes equals to 4 centimeters. So what it means is that it means that here is 4 centimeters. So with this now, it's now easier to get this. It's now easier. This is just like a kind of manipulation. Yeah. So sine theta over 2 sine theta over 2 is equals to sine of any angle is opposite over hypotenuse. So what is my opposite here is 4. The 4 I just found now. 4 over what is the hypotenuse? 5. Yes, 5. So this is a nice result here that sine theta over 2 is just 4 over 5. So let's now put it in this formula. So L is now equal to 2 times what's our R? R is the radius, is 5 times what is sine theta over 2 is 4 over 5. Yes, 4 over 5. So over 1 over 1. I will solve this way because some of us can't, or some of you can't divide numerator and denominator at the same time. So let me solve this way by multiplying the numerator first. 2 times 5, 10. 10 times 4 is 40 over 1 times 1 times 5 is 5. And then 40 divided by 5. We still have that the length is still 8 centimeters, unlike the way I solved initially. So it still works. I just found out that using Pythagoras all through was much easier and faster. So that's it. So the next question 4. AB is a chord of a circle. AB is a chord of a circle, center O. If AB is 24.2 cm and the perimeter of the triangle AOB is 52.2 centimeters, calculate the angle AOB. So let's do a sketch for this question. Let's do a sketch. I think I've sketched already here. Yes, I've sketched already here. So we are told that AB is a chord of center, and the length of AB, that is the length of the chord. Length of the chord is 24.2. AB, this length from here to here is 24.2. That is AB. If A from here to here is 24.2 as we are told. So let me write AB, or let me write length of the chord. So the length of the chord is 24.2 centimeters. Okay, so what other information do we have there? And the perimeter of the triangle AOB. Okay, the perimeter. Now, from primary school, you were taught how to find the perimeter of a triangle. That is just simply adding the three sides. Yes, adding the three sides. So, and this is a circle having a center. So, of course, here should be the radius. Here is the radius, and we are told that AB is 24.2. AB is 24.2. That is here is 24.2 24.2 centimeters. So what else do you have in that question? What other information? Okay, and the perimeter is 52.2. So the perimeter here of the triangle, the perimeter of the triangle is just simply P equals to, it's doing AO plus OB plus AB. Yes. Once you hear perimeter, it means you should add everything around the shape. So P is now equals to, okay, we know our P. Yes, I'm told what the perimeter is from the question, as you can see here, and the perimeter of triangle AOB. So my P already is 52.2. We are giving P already as 52.2 centimeters. Yes, we are giving P already as 52.2 centimeters. Always write out your parameters. So I won't call it P again. I will call it 52.2 equal to, what is your AO? From the diagram here I sketched, AO is just R plus, what is your OB? Is also R. And what's your AB? AB is just 24.2. So I need to get stuff for the radius to have enough information. This is why I'm doing this. So I will have 52.2 equals to R plus R is 2R plus 24, okay, plus 24.2. So let's take like terms. Now taking like terms, we now have that 52.2 is here, plus 24.2 comes to the left and becomes minus 24.2 equals to 2R. So when we add when I subtract 52.2, when I did 50.2 minus 24.2, it's giving us 28. 28 equals to 2R. So to get my radius, I will have to divide both sides by 2. This will cancel out, and the radius is actually 14, because 28 divided by 2 is 14 centimeters. Now don't forget what you're asked to find. You're asked to calculate the angle AOB. Angle AOB. So where is AOB? They mean this angle here. AOB. They mean everything here. Like everything here. Yes, everything here is what we are asked to find. Everything here. So let's call it theta. We have to find everything here. So how then can we solve for this? So if you were in the SS2 class or class 11, I would have said that we should use the cosine rule. Yes, since we now know our sides completely, we know R here, and here complete. So we could still use cosine rule to get this theta here. But since this is a chord, we can easily get this using formula of length of a chord. So I will not say but, sorry, I will not say but as we know, sorry, before that, I hope you know that whenever you have such diagram, whenever you have a center and a line drawn from the center to bisect the chord, don't forget here, this small portion becomes half of the original angle, like that. Here becomes half of the original angle. So length of the chord is equals to, as we know, the formula is 2R sine theta over 2. So that's the formula for length of chord. Formula for length of chord is this. So how can it play a vital role here? Let's see. We are asked to get theta. So my L, length of the chord, as we have initially, is 24.2. 24.2 equal to 2 brackets. My radius is 14. 14 sine. I don't know my theta, so let's put it down as theta over 2 that way. So we now let's continue from here. We now have 24.2 equal to 2 times 4 is 28 sine theta over 2. So to get, we are asked to find theta here. That's our main target here. So I will now have to divide both sides by 28. Dividing both sides by 28. 28 we cancel out here. So what is 24.2 divided by 28? We have, since I'm trying to do a trig problem, so I will just leave my answer in 4 decimal places. I will have 0.8642, sorry, 8643, yes, equals to 8643 equals to sine theta over 2. So to get this, I will now have to do the sine inverse. So this is sine theta over 2 is equals to 0.8643. So to now solve from here, let's take the sine inverse of 0.8643. I will have that theta over 2. To get theta over 2 is equals to the sine inverse of 0.8643. So theta over 2 becomes equals to, what is the sine inverse of 0.8643? Sine inverse of 0.8643, that's 59.8 approximately, is 59.8 approximately. So to get theta, I will have to, this is theta over 2, I can call here over 1, then cross and multiply, so that theta times 1 gives us theta, and 59.8 times 2 should give us 119 point, sorry about, okay, 119.6 degrees, this angle, so it should be in degrees. So our answer here is 119.6. So that's it.